Hello and welcome to Maths with El Profe. In this video we're doing some elementary number theory, and in particular we're going to be looking at reduced residue systems and Euler's theorem. Okay, so as a reminder, if we have m as a positive integer, right, then a set of phi of m integers such that each element of the set is relatively prime to m and no two elements of the set are congruent modulo m is said to be a reduced residue system modulo m. Okay, so how do we find a reduced residue system modulo 15, right? How do we find this set of numbers that will be relatively prime to 15? Well, what we have to do is the following. First, we have to consider, right, what the set is where we find phi of 15, where once again phi is the Euler-Tauschent function, right? So phi of 15 is going to be, right, the magnitude of the set of numbers relatively prime to 15. Well, we know that 15 is equal to 3 times 5. So those numbers, those positive integers less than or equal to 15, relatively prime to 15, are 1, 2, not 3, 4, not 5, not 6 because it has a factor of 3, right? 7, 8, not 9 because 9 has a factor of 3, not 10 because 10 has a factor of 5, 11, skip 12, 13, right? And finally 14. All right, so phi of 15 is going to be the magnitude of this set, and there are 1, 2, 3, 4, 5, 6, 7, 8 elements in that set, so phi of 15 is equal to 8. Okay, now what does that tell us? This tells us that a reduced residue system modulo 15 is given by the set 1, 2, 4, 7, 8, 11, 13, and 14. Right? And in other words, we can find quite readily this reduced residue system modulo m by simply listing the elements that are relatively prime to m. Okay? In our next video, we'll do a little bit of work with Euler's theorem, where we're going to solve a linear congruence in one variable using Euler's theorem. Okay? As you have questions, please do reach out. Thank you for taking the time with us here at Maths by El Profe.